All right, guys, it is Friday, and we are recapping Earth's layers from your investigation yesterday. You should have this Tectonics Explain Earth's Layers completed and submitted from your work time yesterday. All you were doing was using this reading, right, to complete questions about the different layers of the Earth. So we're just going to jump right in. You've got 5 descriptions here. Of 5 different layers of the Earth. So go ahead and have your Explorer activity pulled up on your screen and use that to figure out exactly what layers we're talking about here. So we have 5 layers we're going to name. So this is where the video is going to get paused. Pause the video, talk with your team, figure out what layers you're looking at, and then come back when you're ready. Okay, you've had some time to talk with your group, think about your layers. There's a lot of different layer names, so let's talk through some of these. This first one here, I gave you a few clues. We've got the word ocean, right? Under the ocean, that should be a big clue, and also rigid. So rigid is like firm. If it bends at all, we're going to get some cracking. So that should give you an idea that it's part of the crust. And we, of course, know we have 2 types of crust, and the one underneath the water is, of course, oceanic crust. So that's what we were looking for here in example number 1. Number 2 is talking about the only layer that is liquid. Lots of different layers in the Earth. They're all solid except for this one layer, and it's made up of mostly iron. It's a more dense layer, it's a hotter layer, and it's only liquid. That one is going to be the outer core. Okay, strange, but the outer core is the only liquid layer. Okay, next, number 3, uppermost part of the mantle, hot enough to flow, or plastic-like. This was a description that you read about in your investigation yesterday, and you've probably heard me say it as well. Plastic-like, not like made of plastic bottle, but plastic-like in terms of hot enough to have a flow. So this layer is still solid, but it's super heated, so it has a slow movement. In class one day we talked about like silly putty or toothpaste, how it's a solid but it can be formed a little bit. And so that one is the asthenosphere. And you can see on our picture here, it's that top part of the mantle. So this section here, that's the asthenosphere. Next one we're looking at, number 4, solid iron. So back to that solid state, most dense layer, that's going to be down here with the inner core. Inner core is the most dense, right? We know that as we go from the Earth's surface to the interior, we see a couple characteristics increase. So layers are more dense as we get towards the center. Remember, density is like how compact or how heavy the object is. So if we think about it, the heaviest stuff sinks in. We also know that this is the hottest part of the Earth, right? The interior is the hottest, and there's the most pressure down here. We're seeing all this other material stacked up on the inner core. So there's the most pressure, most heat, and most density down here in the inner core. And finally, the last part here, the thickest layer of Earth. You can probably see that here on the diagram. That's referring to the mantle layer. And you maybe heard it called in your investigation there, the mesosphere. So you might hear both of those as we continue on with our discussion. Okay, so those are some of the layers that we're really going to get to know as we keep going with our idea of plate tectonics. You have a picture here kind of showing all the layers, again, just showing the sizing and the spacing of each one's, but this upper mantle, right, this is also that asthenosphere right here. So we're kind of looking at this little wedge of the Earth. And we have been talking about this outer layer as the crust being broken up into these two different types, continental and oceanic. And one of your questions in your investigation was going through some details about those pieces of crust. So this is your number 6 on your investigation. Go ahead and scroll to your number 6. We're going to do a pause again here, and this is where you can check with your team and compare and contrast your answers. You should have one of these 2 words recorded in the box. So between these 2 types of crust, one is the thicker, one is the thinner, more or less dense, and then iron rich or not. And I did give you those rock types there. So do a quick 30 seconds with your team, compare, and then we'll come back together. All right, you had an opportunity there to check in with your neighbors. This should be quick. We've seen a few really nice diagrams outlining what these crusts look like. So the first one here is thick versus thin. So in this diagram, we can see that the continental crust is the thicker piece compared to the oceanic crust. It's much thinner. It's being compressed by the weight of the water. And it's also just a different rock type. It is something called basalt. Okay? Basalt is an igneous rock. Talked about those earlier in our unit. Those come from volcanic rocks, activity, cooling, magma, or lava. So our oceanic crust should be thin or thinner of the 2. And in terms of density, again, we're thinking about being compact and being heavier. So looking at our picture here, we see the continental crust sitting above the oceanic crust. And the oceanic crust is sinking down underneath because it is the more dense of the 2 pieces of crust. So oceanic crust is more dense. That rock type of basalt is more compact. And this is the more iron-rich of the 2 rock types. So that's what you should have on your chart. Okay? Thinking about continental crust then, that one is made up of granite. Granite is also an igneous rock type, but again, they look a little different. This is what we're seeing, pop up in kitchens. It's a little more visually pleasing because of those big crystal size, because it cooled inside the earth. When we look back at the picture, with my scribbles on it there, we do see again the continental crust is the thicker of the 2, right? I like to just remember it's creating those big mountains for us on Earth, so it is the thicker of the 2. It does sit a little higher on that asthenosphere part of the crust, so it is the less dense piece of crust, and then it is the not iron-rich piece. So we're going to start hearing a lot more about those 2 types of crust and starting to look more at how they're interacting at our different types of boundaries. And really, now that we know their characteristics, start thinking about why they're interacting that way and what kind of features we're getting because of that. So make sure you have all the right info there in your number 6. So I always get this question, well, how do we know, right? So much of this unit is theory because we can't go into the earth or look at it from the side like in these diagrams. So where do we get this data from? A lot of our layer data is coming from earthquakes. Earthquakes create shock waves that are sent through the different layers of the earth. And those shock waves, there's a few different kinds. They all travel a little differently, and they travel differently through each layer because of what the layer is composed of, or solid versus liquid. So not only its state of matter, but also its ingredients, if it's iron or magnesium or silica, rigid or plastic-like. And so what we do is we track where the earthquake waves start and when they reach these other points, and that gives us clues to what it really looks like inside the earth. And so that's how we get this thickness idea of each of the layers, because we certainly have not and cannot at this point drill down into the Earth's interior. So here's the last one I wanted to do with you guys today was this number 12. Go ahead and scroll down. Look at your diagram here for your number 12. You are labeling up some of the layers using this diagram. You had this list in your number 12 that you were working from. So one more time, go ahead and pause, check with your teammates, your neighbors, and see what you came up with for your labels, and then we'll come back together. So a quick 60 seconds. Here we go. So I like to start with the ones I know for sure, which to me are the cores. The cores are nice and easy to get labeled. Inner core, of course, the most interior, and then the outer core. So you should have those labeled pretty fast. Another one we should know by now is the crust, okay? The crust is kind of this darker brown layer up top. And there's two spots that it's pointing at. We have here with the mountains, and then here, spoiler alert, underneath the ocean. So our two crusts should be able to be labeled quickly. We have our continental crust and our oceanic crust, right? Our O and our C. Now that leaves a few layers for us. We have the asthenosphere. That was our plastic-like layer we've been talking about. We have the mesosphere, which is the bottom section of the mantle, which we know is the thickest layer. And then this lithosphere we haven't really talked about yet, at least together. You read about it in the investigation. But what the lithosphere is a combination of the rigid layers on the top. And so it's really a combination of the crust and the top of the mantle. And so the lithosphere is two layers in one. So hopefully that clues you into what we're looking at here. It's this guy, the lithosphere. So it's this crust layer, both continental and oceanic crust, and the rigid layer underneath. And that lithosphere is really what the tectonic plates consist of, all that solid, cold, rigid rock. Right underneath there, then we have our asthenosphere, that's this orange one, the plastic-like layer, and the last one is our mesosphere, the remaining part of the thick mantle. So this should be a picture that you're becoming familiar with. Again, we have those ones that hopefully we know, right? The outer core, inner core, and the two crusts. We're just really going to have to practice that the lithosphere is those two rigid layers up top. Asthenosphere is that plastic-like layer, and the mesosphere is the bottom part of the mantle. And as we talk more about the tectonic movement, we'll see that these, while being both part of the mantle, just have different characteristics. So here's what you have left going on today. You've got two things that you're thinking about. One is that homework check retake for our Tectonics 1 homework check. That is now open and available. You should be able to crush through that after looking at your feedback yesterday. And then the second thing you're looking at is learning targets, working on 1 and 2. And our goal is to get those submitted today. And I understand when you turn this in, it will only be learning target 1 and 2 completed. The rest, I understand, will be empty, but as always, we'll get there. So as you can see, this first one is about layering the parts of the earth, or labeling the layers of the earth. And then you also have a picture to label with continental and oceanic crusts and give details coming right from that table that we look at. So you'll see every learning target here has every learning target here has a visual to label and a question to give some details on. So you're doing a little bit of both in each learning target. As always, just a reminder that in the unit review folder, you will have a video for each learning target, just a quick summary if needed, to go back and make that happen. And to be honest, this video really does that too. So good work, guys. Looking forward to see those retakes and learning target submissions rolling in. See you soon.